use variation of parameters to solve the given system. So to use parameter methods, first you need to find homogeneous part, then find non-homogeneous part and add them together, which gives you final answer. So here's the steps you need to do. It's not step-by-step process, but I will walk you through it. No worries. Okay, let's take a look at the problem. So you have this one. First, you need to have A minus lambda I. Let's call this matrix A and then subtract it with lambda I. That gives you this matrix. Very simple, very straightforward. You've done this many times. And then find the determinant of A minus lambda I. Set it equal to 0. Solve for lambda. You will get positive negative I for lambda. Use lambda equals I. Plug it into here. That gives you this matrix augmented with 0. From your first equation, you know that ik1 is equal to k2. If I choose k1 1, then k2 is I and my vector k is 1i. Then it's time to write our homogeneous part, and our homogeneous solution is equal to c1 times open parentheses a real part of vector k, which is 1 0 times cosine t. This is actually cosine 1t, where the 1 comes from. So this one comes from the imaginary part of lambda, okay, minus the imaginary part of vector k, which is 0 1 times psi of t, and then add c2 times second solution. Because this is complex eigenvalues, you can obtain second solution easily from the first one. So duplicate the first one but you need to change something. So first one you have minus psi, for second one you need to have plus psi. Cosine psi stay the same, and for these two vectors switch their position. That gives you second answer, okay? And if you work further, you can simplify it down to this one. So multiply this in and then subtract them together. That gives you this matrix. Multiply this in, add them together, it gives you this matrix. Very straightforward. Now it's time to find non-homogeneous part. So similarly, like A minus lambda I, for non-homogeneous part, you need to have phi of t, which is the vector that you obtain from homogeneous part. Exclude c1 and c2, put the rest into this matrix. Then find its determinant. That gives you 1. And then you find its inverse, which is equal to 1 over the determinant times this matrix. But you need to change something. So in upward diagonal line, multiply by -1, which gives you this. In downward diagonal line, switch their position, which is nothing changed because they are the same. Alright. And then you need to find u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is this thing right here. So multiply them together, it gives you this matrix. Okay, so I have a little note right here. So when you multiply matrices together, do not switch their order because it will affect your final answer. So it's not like when you multiply variables or numbers together. Just keep in mind that. Okay, you have this one, simplify it, you will get this, and do it one more time, you will get this one. So let me explain this a little bit. So 0 0 sine for cosine square. Remember, you have trig identity that's saying that sine square plus cosine square equals 1. So I have cosine square here, so it is the same as 1 minus sine square over sine. So simplify this one more time, you will get this matrix, and simplify it now one more time, you will get this very simple vector. Alright, after that you need to find the integral of this vector, which gives you 0 natural log of cosecant t minus cotangent t. Okay, now it's time to write our phi non-homogeneous part. So it is equal to phi vector is equal to phi of t times u of t. Phi of t is this one, u of t is what you just found. Multiply them together, it gives you this one. Again, do not switch their orders. I mentioned this many times in my videos, and I hope it sticks in your mind. Okay, now your final solution is equal to the summation of homogeneous part and non-homogeneous part. Okay, so just add them together, it will give you final answer. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.